And the next speaker, Michael Christen, will tell you more about this, about a peer-to-peer search engine. And he's the developer of the peer-to-peer search engine Yassi. And this is an opportunity how anybody can connect in global mesh of search engines, which are based on private persons. Now, this system of private search engines or half-private search engines may be organized in different ways. The peer-to-peer example is, say, the most decentralized system one could imagine. You could order it a bit more in a hierarchical way. This was the system I thought of when I mentioned the universities and libraries who might run smaller search engines and combine them by meta searches to global search. These are all opportunities and possibilities one has in this field of general opportunities for running search engines. Now, when I said anybody of you could run a search engine, there must be software available for it, and certainly it is. This is the list of search engine software, at least the one we have tested at Hannover University, and which run more or less comfortable. Right now we actually have two possibilities. Search engine project Nudge, you may have heard of it, is a free software project based in San Francisco with many attendants around the world, in Germany too. And the other side is the peer-to-peer search engine Yassi, and this is actually a real plug-and-play software. None of the other search engine software here is plug-and-play. If you download it, you have to get into it and get involved. But Yassi actually runs as the one and only search engine software as a plug-and-play software, and Michael Christen will tell you more about how to install and what it does and how it works. Thank you very much.
Thank you, Wolfgang. Good evening. I'm the architect of the peer-to-peer search software Yassi, and I want to tell you something about it. First, what is it? What can it do? It's a search engine containing the standard elements of a search engine, the crawler, an indexer. It has its own built-in database, and it has a search interface based on an HTTP web server. The web server is running on your computer, and this is all in one simple to install application. But we also added a peer-to-peer network protocol to the search engine, and so the search engines can connect to each other. So what can you do with a peer-to-peer network protocol on a search engine? Parts of the protocol is to send parts of the index to other peers, which you can see on the left side. And you can do a crawl in your peer, and you can also distribute parts of the peer. So every peer can send parts of the index and parts of its crawl to other peers. And the most important thing that every peer should be able to receive from other peers is it can receive index fragments from other peers when it does a web search. So the next question is, how should peers be connected in a network? We have two choices. One is connect peers in a hierarchical way, like you see on the left side. But this means it's a centralized technology, and you also need people who moderate the connections between the peers. It can't be spawned automatically. And the other option is to build up a completely decentralized network, as you can see on the right side. It looks a little bit chaotic, but it's not. There are well-known technologies to organize such networks, like using a distributed hash table to organize the data. And that's what we do. And actually, the Yassi network looks like the network on the right side. And I show you a picture of the network. This is a drawing of the network 2 months ago. And the dots at the circles are Yasi peers. Around it are names of the peers, and we organize the data with a distributed hash table. And there's no central server who organizes that. The network is completely self-organizing. So how can a search can be done in such a network? I will give you an example. Consider the peer on the right side is your own Yasi peer, and you do a web search with that peer. That means you open a web page on your local host. It's a local. The standard is localhost port 8080, and you have a search interface like you know it from all other search engines. And if you start a web search, then your peer computes where that part of the index in the network should be, and addresses those peers directly. It doesn't scan all the other peers. It just connects to some specific peers which should have the index. And if they have something, they send it back. They are collected and consolidated like a meta search would do it. They are then ranked afterwards, sorted, and given back on your own search page. The next question is, how can these other peers can have exactly those indexes as they should do? So if you want to address them directly. It's an example of a crawling. Your peer may start a web crawl. You crawl over web pages, do an indexing, and if you have enough index files, they are distributed to other peers. You can imagine it's like a file sharing network, but they are not generally files shared, but only index fragments are shared through all the peers. And they are organized in such a way that the peers get only those indexes as they are expected when some other peer does a search. So they can be addressed directly, and this is relatively fast. We can do a web search now within 6 seconds. It's still much longer than you search with other centralized search engines, but we are working on it, and I think 3 seconds is possible, so this can be really used as a web search engine. The advantages are clear. You can't do a censoring in this network. There's no censoring. It's not possible to take out globally information from it. Every peer owner has the right to remove information from his own peer, but he can't influence the other peers. So maybe someone can remove one part of the information, but not from all the other peers. And if the web index is distributed, it's distributed in some redundant way, so that some information is always available in several places. And not one only peer can remove all the information or one word or one web page from the index. And everyone can put information in the network. So yeah, everyone. This is kind of a tool of information freedom. Everybody can put information, and this can be done in a cooperative way, because there are the network protocols to start distributed crawling, and so the software is open source, and everybody can see how it works, and that there's effectively no censoring. So this is all about information freedom. It's possible to create a web information freedom with it, and now it's on the user to make this true. So everybody should participate in it. Yeah. The problem is if there are too less peers, the information is low, and maybe there are not enough people who like it because the information is bad. But the more people participate, the better gets the quality, and maybe then more people think it's a good tool, and this makes even information better. So I hope you all join this in the Yasi network. Thank you.
Okay, hi. My name is Frederik Thiele, and I'm a project leader at the Search Engine Lab at the University of Applied Science in Kaiserslautern. And there was a lot of theory now, and now I want to show you some practical examples. My topic is hacking the box, and let me see what I can do for you. First, I want to give you a short overview about this topic, and then I show you some interesting examples. Okay. Now, most people, I hope not here, think Google is just a search field where you just put in 3 words, click the search button, and get the best result. But there's a lot of more about Google, and there are a lot of advanced search functionalities in it. So you have here some examples. You can combine some keywords to exact phrases. You can combine keywords with some OR. You can exclude some keywords like spam or eBay in this example. Or you can search only for specific file types here. Then you can only search in the title of a web page or in the body text of a web page. You can look for special keywords in the URL, or this is an anchor thing, is you can look when other websites link to your web page. You can search which keywords they use to link to your site. It's the same with the miserable failure example Mr. Beuermann said. So, and the last one is you can only search for special sites. Like here, you can just search for edu domains. Okay. Okay, what's the status? We have a big database with over 9 billion documents. And we have a really powerful search functionality. Okay, we can search for normal informations, but that's not so funny. So let's have some fun. But first, all I will show you now, it's not Google's fault, I have to admit this. And it will also work with Yahoo, MSN, and others. Google is only the provider. And don't try this at home. So let's start. Can I have this microphone? Yeah, hello? Okay, then take it. Okay. So first of all, I will now show you some examples how you can really use this advanced search functionality to find interesting things in this huge database. So first of all, I have some examples in the area of data privacy. No, it's okay. First of all, I searched for some EDU sites, just as schools in the US, for some grades. And if I look here, I get some really interesting information about grades from some students, from Professor Lawrence A. Rove, with detailed information about the work of the student and so on. I will not that you can find this for my work. So let's take the next example. You can also look, if you need some private information, you can look for some CVs online. And we only take this one with emails online, address online, and phone number. So there's a lot of information about all these people. Maybe we should call them. So let's go a little bit deeper. We have this Google example. Maybe you all know this FTP client, the WSFTP. It's a really old one. And it stores all your passwords and your sites in this file, in this ini file. So maybe we find some of these files online. Let's take a look. Oh, okay. No, wait, this is a Google example. Okay. Here we have a lot of these files. And here we can just go and download them. Okay, but I've prepared an example. It took you just 5 minutes to figure it out. This one. And you see here, if you scroll down, there are some good examples of the